Shear force at any point along the beam is a force that tends to produce a sliding failure on the material along a plane that is parallel to the direction of force. Bending moment is a moment indeed in a structural element such as beam when an external force is applied to the element, causing the element to bend. The apparatus to measure shear force can be presented by the apparatus shown. This is example. We have 4 points A, B, C, and D. Then we cut at the point X here, and measure the length. For case 1, a load of 10 Newton is placed between A and B. A, B, C, D. So we put load on between A and B like this. Then the load of 20 Newton and 30 Newton are added like this. I don't have many equipment, so I just use the what I have. Then case 2, repeat by replacing the load at any point between B and D. A, B, C, D, B and D. B and D, we put here. We put here the load. Repeat by replacing the load at any point between C and D. C and D. So we put load between C and D and measure the distance and the load, the weight of load. Next, the discontinuity of the rock. Sorry. Okay, that's all.
Positive shear force and negative shear force. For objective 2, we use the measure shear force from the previous part and plot shear force diagram for each case. The measured shear force will be positive or negative when the applied point load is placed at the different part of the beam. Take case 1 as an example. This is the shear force diagram and the measured value of shear force is shown.
This is the replica of shear force due uniform distributing loading test. And here was the point A. Here is the B. Here was the XX cross-section. And here is the D. For shear force due to uniform distributed loading, first, apply at least 3 same magnitude point loads next to one another. Make sure the distance of each other is the same. Calculate the uniform load by using this formula. And then calculate the value of shear force at cross-section XX.
Hi! There are 3 cases in Benimovan variation at cut due to variation of load and position of load. First step, for case 1, different load P is placed between point A and point B. For case 2, different load P is placed between point B and point D. Finally, for case 3, different load P is placed between point D and point C. After that, measure the value of bending moment at point D or at section XX for all 3 cases.
In the experiment, we need to set up the apparatus, First, we need to put load W at point A. Then we need to select location to put load P, whereby in this case it will be putting between point C and point D. Then we need to measure the distance D between point C and load P. To find the value of P, we can measure the bending moment at section D, XX. Finally, we can compare the value of bending moment at XX section experiment value with the theoretical value.
To prove the superposition principle, first, measure and calculate shear force at section XX for different places of point load. Then, calculate the force by applying the superposition principle. Then, we will discuss whether the calculate and the measure of shear force at section XX obey the superposition principle.
After we finish measure the bending moment, we must calculate the bending moment by using few steps and equation. First, we obtain the reaction at point B by using the equation summation of bending moment at point C is equal to 0. Next is to make a cutting at section XX so that we can get the bending moment by using the equation summation of bending moment at point D is equal to 0. According to the superposition principle, the total bending moment at section XX is equal to summation of bending moment at section XX when the load is at point 1, point 2, and point 3. Finally, we obtain the measure and calculated bending moment at section XX. We compare this value to see whether they obey the superposition principle.